And I'm going to start my talk about edge compute in AWS. So before we proceed, anyone ready to tell what is edge compute? No one. Okay, I see a hand raised. Can you please give a mic to the person? Edge compute.
So edge computing, when you move the computations close to the customer.
Right. You're exactly right. So edge compute, I always forget that I have to look at one place and say, use my remote at another. So yeah, it's a technique when you're moving your computations as close to your customer as possible. So what do we mean under compute services in general? So we already discussed GCP, we discussed serverless in Azure. What do we mean under compute in AWS? So three things, essentially. So let's try how our laser remote working. Everything's fine. So first of all, EC2, Elastic Compute Cloud, virtual machines, for those who are unfamiliar. Then Elastic Block Store, EBS, also can be counted as compute because obviously compute is relatively impossible without storage. And then if you're into serverless, if you love fancy things, you may use Lambda. Of course, there are EKS and ECS for orchestration, but essentially compute on AWS, EC2, ABS, and Lambda. But are we going to talk about them today? No, we're actually not. We're going to talk about edge computations, as a person from the audience already mentioned. So it's a way of processing the data closer to the data sources for reducing latency and improving the speed, and enabling a lot of applications to work, such as IoT, mobile, vehicle to everything, and many more. How do we use it in AWS? Which services can we use for it? First of all, before we move to the services, in Announce, we have promised to give an answer to the question, was this thing ever existed before cloud? Any thoughts from the audience? Yes, no, just hand raised. If you think yes, raise your hand. Yes, okay, so I see a few hands raised. The answer is yes. And initially, under edge computations, we meant computation-side branch offices of huge companies, enterprises, opposed to computations at the headquarters. So it was like early 90s. Then we have first CDNs. And in CDNs, when you're caching something, theoretically you run some cache server, you are making the computations by running the server, and then, yes, edge compute become a computationals on CDN. And in the modern world, yeah, it's about moving computationals as closest to customer as possible. What do we use for it in AWS? So let's actually start from the bottom as an entry-level thing. So first of all, local zones. We're going to talk about it really soon. It's a way of adding certain cultural or metropolitan center to your availability zones and run your compute there. After it, CDN level, AWS Lambda Edge and Amazon CloudFront functions. You can run computations on CloudFront level. This is CDN in AWS, and move it closer to the customer by this way. If you're more sophisticated in your request, and if you want to have edge compute in disconnected environment, in tough conditions, Snowball Edge is your choice. For many of you, I'm sure this service is known for basically a huge flash drive to migrate the data, but it's actually suitable for edge compute as well. Moving forward, AWS Wavelengths, 5G computations on base stations level, basically on the pole, where things that are allowing 5G networks sits, and we also can perform compute there. And if you want to have piece of AWS in your data center, in your premises environment, AWS Outposts is a thing that you might go with too. Okay, so why should we care in general? Why should we care about moving computational as close to customers as possible? Well, because a lot of things cannot work with it. Vehicle to everything. This is probably not the thing you ever heard about, but many things in modern world are going to work based on communication of vehicle to traffic lights, to other vehicles, to smart system, and these things cannot work without edge computations. Any real-time ML automation cannot work with it. You probably heard about Apple Vision Pro, this device. Most of applications for it are going to use edge compute in any way. Manufacture, when you have a huge manufacturing facility, edge computations is also a place where you might set up. So a lot of places where money are. Moving forward, let's talk about local zones, entry level. Very easy to start working with. You're just going to your AWS organizations, you're opting in, you have to opt in for local zones, and you see basically another availability zone in certain region. These availability zones are located to huge industrial control centers. They're connected to AWS services in their main regions, so the regions they're attached to because it's technically just another availability zone. And they're helping you to deliver low latency applications. If you need to deliver video content, if you need to use ML computations with lowest latency possible, if you're setting up servers for your real-time game, for your online game, and you want to improve your user experience drastically without a huge curve of entry into the edge compute world, you can just opt into local zones. And actually, there is a local zone in Warsaw. So you can see purple dots on the map here. These are already existing local zones. You can see green dots on the map. These are local zones that are going to be set up. Most of them, as for actually many of AWS services, are in the United States, but we actually have availability zone in Warsaw, and many companies are already using them. All right. Moving forward, let's talk about 5G. Let's talk about AWS Wavelengths. Wavelengths is a service that helps you to integrate compute and storage. That's I want to highlight it. Compute and storage, very simple services, to telecom networks of certain providers that are partnering with AWS. They're designed to minimize network hops and leverage capabilities of 5G, basically as throughput, the network, and deploying these applications into wavelength zones. You're allowing your vehicles, your drones, your IoT devices communicate with your computational powers as quick as physically possible. And yeah, this is actually a base station with a 5G equipment set up, and probably in this box, it might be AWS compute rack. You never know. How does this work in terms of diagram? I'm not sure, by the way, the diagrams are well visible, especially on the last row, but I'll try to verbalize it. So basically, to reduce latency and set up your applications in a wavelength zone, you are enabling it, you're opting in into wavelength zone. It appears as an availability zone in your region, and you have to work with only one new construct in AWS. It's a carrier gateway. So you're setting up a carrier gateway. It's basically entry gate for a traffic from the internet and the traffic to telecom provider network. So it works in both directions. And you can have your instance that, for example, like a web server in this diagram, SSH connected to your API server and basically acting as a front end, and you don't need such low latency. You don't want to spend much funds. You want to be cost effective. You can be in the public subnet, and in theory, they can be in one VPC. Moving forward, what you have to do to set it up on an infrastructure level? Can you use the same conception, same contracts that you're working with classic EC2? Yes, you can. You have to use carrier gateway. You have the same tooling such as routing tables for it, so you can set up where traffic goes. Yeah, actually, you can see my remarks here, by the way. Yeah. Same constructs, ACLs, everything. You can use it there. I didn't follow hardware, obviously. Here on this table, I hope it's big enough to see, I found certain instances types that you can set up in Berlin waveless zones. So first of all, you can set up only like three constructs here: EC2, EBS, and ALB. So EC2 virtual machines, EBS the volumes, it's a block storage, and then ALB, your load balancers. You have only 4 instances to choose. C3 family, cost effective, like cents for hour, and then you have options for read optimized and GPU optimized instances with built-in SSDs, and you can do ML basically in these wavelength zones. EBS pricing is more expensive compared to other regions. It's 15 cents per gigabyte month of provision storage for GP2, so it's better to not store in wavelength zones anything that you're not actively using. Where do we have wavelength zones? So first of all, I took this slide from AWS Pro Materials, let's say, and you can see the date, May 2022 here. Actually, since then, there is only one region that was added. It's Manchester in United Kingdom. Other than that, this map is still relevant. So unfortunately, we don't have it in Poland. And we have 3 cities in Germany that are close to us. It's Berlin, Dortmund, and Munich, enabled by Vodafone, and a lot of cities in the United States enabled by Verizon. Few cities by KDDI in Osaka and Seoul. In Europe, let's say, wavelength zones are not established yet, but AWS has a great plans of setting it up. All right, interesting use cases, most interesting thing, where we can use it. So I also found this information publicly. Probably there are more cases. Most interesting of them, let's start from the bottom, actually. These are Drone, deliverycanada.com, and the Drone company. Both of them are using it to work with drones. Drone Delivery Canada using wavelength zones to allow their drones to communicate with the API and enable precise delivery. The Drone using their API to basically prevent drones from flying. Also, it's widely used in sports. A company called Shot Tracker. They're tracking the football, American football, baseball matches, and tracking event of goals. And they're using wavelengths as well on stadiums and other things. Keyless and Inception are both using them for ML, one for biological data, for matching your profile basically with snapshot saved in their system and doing it really fast. Define and Harman are using them for automotive. They're using them to enable vehicles to run in a complete autonomous mode. All right. Let's move to Amazon CloudFront at Edge. You don't have to set up another availability zones here compared to local zones and wavelength zones that we just talked about. And you basically have 2 concepts here. CloudFront itself is a CDN. It's a content delivery network helping you to distribute the content around the world. There are a few points on the map, such as edge locations and multiple edge locations and regional edge caches here. And in Europe, we have slightly better presence than in the United States, which is rare to see, but still, this is how CDN work. You cannot ignore huge locations, and all the computations are happening on edge locations here. So at edge location level, at blue dots. Both of the solutions allow you to use a good custom code, but let's compare them precisely. So Lambda Edge, first of all, what is this? This is similar to Azure function that Alexei actually mentioned. And you are setting up a Lambda saying that it's going to run at Edge by adding a few configurations through a CLI or management console. And you can integrate it on a viewer request and viewer response level, as well as origin response and origin request level. And it can be huge. It can use up to almost 3 gigabytes of memory. it can be up to 30 seconds of duration. And remember, this scene is actually sitting between your user and the response. And it's probably not the thing that you want to run for 30 seconds, obviously. And it scales relatively well, up to 10,000 requests per second scale. Well, you might want to use it if you need to resize an image, for instance. Your user uploading an image, you are resizing it, putting it in the CloudFront cache directly, and serving it right off it. So you can utilize relatively heavyweight Lambda Edge functions there. What about CloudFront functions? What about if you don't, about the case when you don't want to use something heavyweight? CloudFront functions, you cannot write it in JavaScript or Python. You can write it in dialect of JavaScript under old standard ICMA 5.1 with limited support of ICMA 6 syntax, such as promises. You can still use promises here. AWS promotes it as sub-millisecond fast, and it's to achieve this goal to fulfill these numbers. It can use maximally 2 megabytes of memory. It has no network access, while Lambda Edge has it, and it can be only here, view request and view response. But it scales up to 10 million requests per second, and this is really fast. And that was a review of CloudFront capabilities in terms of edge compute. Let's move to the hardware. Let's discuss more interesting and complicated things. So Outposts, as I mentioned, is a way of moving cloud into your data center. So it's fully managed service that extends your on-prem data center or your computational center, it might be no data center, with AWS infrastructure. It's ideal for workloads as all of edge compute services where latency is critical. And it helps you to set up services such as EC2, EBS, S3. You can set up S3 in your data center and RDS directly near your customer in your data center. And, which is very important, it provides you consistent experience. So in theory, you might ask a question, why should I order the hardware from AWS? I don't like it. I might order the hardware directly from the vendor and then use it. But if your developers are not familiar with bare metal, they're probably going to struggle. And if you're ordering Outpost, API physically is the same. They can use the same SDKs, the same tooling, the same way of deploying the software how they like it. And your developers will be grateful. Let's try to have a look at the Outpost itself. So Outposts are looking like this. This is actually 42 units rack that looks like this. It's around 2 meters tall, slightly higher than me. Or you can just order like one piece of this rack called server, size of 1U or 2U. So this is 2Us and this is 1U, and this is how it looks like. Compute on Outpost. What is the difference between rack and servers? So it's very simple. It's different in service scope, deployment type, capacity and scale, and networking. So let's talk about capacity and scale. You're ordering a rack when you have a lot of money, to be honest, and you want to use it for larger workloads. It's a full-size server, and you can perform a lot of computations based on it. If you're having a shop and you need to have local compute of AWS to run your kiosk, probably it's better to use one U-size server. Scope is different. Racks are supporting a lot of services, so you can set up a Kubernetes there. For servers, EC2 and EBS, same as for wavelength zones, very basic level stuff. Deployment type is also different, as well as networking. So when you're ordering a rack, you have to provide power redundancy. You have to provide cooling. You have to provide a lot of things. Basically, set up a grown man level server room. For servers, Outpost servers, you can set it up pretty much anywhere. You can set up it near the scene and it will be working fine. Hope it's visible well enough, as well as for tables. I'll try to verbalize it. To compare the price and how does it looks like, you have server with resource ID, whatever that means, or something. On-demand price, 6,500 monthly. So this is your entry level for servers. For racks, starting from 800, much cheaper. And compared to GCP and compared to Azure, you actually might order server with Gravision 2 processor. It's an ARM processor, and you can set up ARM computations directly in your data center. Or you can order the Intel, which will be more expensive, but still. This is hardware costs and how it looks like, how it works in terms of networking, how it connects to AWS Cloud. First of all, it requires constant connectivity. If you want to work with Outposts, you need to have constant connectivity, and you have to work with conception called local gateway. You're setting up a gateway on your networking environment, on your infrastructure, and using it to route traffic to AWS. You can do it with a direct connect. It's basically a fiber cable that goes from AWS Cloud to your data center, or you can use through set up another gateway and use a VPN to work with networking. So it's more sophisticated setup compared to anyone that we had a look before. How does it look for governance? How do you manage your outposts? Very simple. This is actually a screenshot from console. Your order is outposts. You see that it's a menu with a few things, outposts, sites, and local gateways. You configure everything here. You're ordering them from management console, actually, and you're managing the outposts from this place as well. So it's very, very simple. Same UI, nothing to get familiarize yourself with. What about outpost security? How do you specify security for such thing? Same amount of tooling as for wavelengths, same amount of tooling as for all edge computational services on AWS, but with certain specifics. Anyway, you can use VPC endpoints. You can obviously configure flow logs to gather from them. You can feed these flow logs to inspector, guard duty, system manager. It's tools for analyzing vulnerabilities and preventing security incidents by performing mathematical actions. Also, you can use root tables. Also, you can use ACLs, IAM, security groups, everything you like. So it's a very consistent experience compared to rest of the AWS Cloud. And let's move to the Snow Family. And actually, it's a thing that I'm going to demonstrate you. We have a Snow Family device here. But first, I'm going to tell you what the heck is Snow Family device. So it's actually a family of 3 device types, Snowcone, Snowball, and Snowmobile, different in sizes and initially designed for moving your data from cloud to your on-premises environments or vice versa, for data migration in general. Snowmobile is it's basically a truck helping you to move 10 petabytes of data or more back to cloud or from cloud. Snowball is a little smaller, and Snowcone is like tens of terabytes. How is Snow Family compared to Outpost, you might ask? Both of them are doing compute, both of them are edge services. What should I order? So deployment type is different. Outposts require constant connectivity. You cannot set it up anywhere, work in interrupted connectivity environment. You have to use Snow Family for it. Moving forward, connectivity and deployment type is different, of course. Snowball device is mobile. Use cases are also different. So for Outposts, it's designed to be used when you want to have a hybrid cloud, when you want to move cloud closer to you. For Snow Family, it's truly designed for edge computationals in a place where internet connectivity is under question, where your even the power supply might be under question when environment is truly tough. Scale is also different. Outposts are massive, as you previously saw. Instance type are huge, and for Snow Family is much more modest. And let's move to the Snow Family itself. It's actually a Snowcone, and we have such device here. It's small racked, enabled with Wi-Fi and LTE. It's HDD of 8 terabytes or SSD up for 14 terabytes. It's equipped with 2 vCPU and 4 gigabytes of memory, actually driven by very energy efficient Intel Xeon family CPU. And it can be used for gathering data in such industries as mobiles, healthcare, field operations, remote surveillance, whatever you can imagine. Services you can run on these things are also kind of limited. AWS IoT Greengrass, EC2, EFS, exposes through NFS endpoint, EBS, that's it. Snowball Edge devices are kind of bigger. Here's a dog compared to the Snowball Edge size, and it's around 20 kilos. It's allow you to have up to 210 terabytes of storage on one device, on one such thing, and you can order multiple of them to migrate the data. The scale actually is the reason why Snowmobile is slowly going to be deprecated. Computational power is up to 104 vCPU, 400 plus gigabytes of memory, and even P3 GPU option. So you can do ML, you can do data analysis, whatever you like on the GPU, directly near your customer or near yourself. And where does industry using it? Actually, most of the cases are related to private 4G and 5G networks because computational power is not very big. Obviously, certain companies such as SmugMug are using it to gather live videos and photos from events such as ours and processing them before sending them to S3 to object storage. United States Geological Service actually used this device. You probably heard about the story. It was in AWS blog post. Use Snowball Edge devices to migrate the data from server room that was located near erupting volcano. So basically, they were saving the data, and the environment was extremely rough, as you can imagine. Yeah, and Deluxe are using it to capture and processing videos and photos as well as SmugMug. So much less extreme case. And it's actually time for a demo, and Anton will help us. Can you actually show us the device?
Sure.
So
Yes,
here is the device.
I'm very sorry. We really don't want to move it because the cables are funky and it's just going to power off. But you can take a look.
You can take a look after the demo. So idea is we're running the ML model here. And basically, this model attached to the input of Anton's MacBook web camera, and it's going to count persons in this room.
Yeah, but before that, I think it's worth iterating that it's essentially, you see a lot of cables here. It's essentially like an offline setup, right? So there is a laptop because we need to do something, and there is a device. Let me connect the projector.
Yeah. If you help yourself with the projector, you can actually use it.
Why is still showing this?
Because it's a demo time.
Okay.
Have a go on.
Fair.
You need demo. Do we need the devs to do a demo? No, I think we can figure it out. All right, we see something. We see that it's rebooting. I mean, the projector itself. All right. Yeah. So here is the console, how it works. As I already mentioned, experience is very consistent to what you have when you're working with remote AWS environment. So do we want to run the describe instance command?
Yeah,
of course we want. Let's run it. The only difference here, can you scroll a little bit on top? Yeah, so the only difference here, we specified the endpoint, and it's local. This is the local subnet. And the response is very similar to what you have in EC2, except that you have a lot of assets here in image ID, instance ID, and an instance type itself. It's a Snowcone small instance. All right. You can use pretty much everything you like with EC2. Using the console or using the UI. Can you show us the UI, please, Anton?
Sure.
Yeah, here's the UI. A lot of errors, but believe me, it's working. It's working. Remember, it's a remote environment. Okay, we have one compute instance here running. We have our network IP addresses. We have our SSD storage. We have a lot of things here, and EC2 compute running. All right, let's move to EC2 compute.
Sure. So as you can see, we have the one EC2 instance launched. It's a pretty tiny one.
Its launch name is running.
As Kiryl mentioned, we've got just 2 vCPUs, which probably suggest like a single core and 4 gigabytes of memory. So you can't do much. It's essentially a very, very fancy flash disk, right? If you want more compute, you can use the Snowball Edge device, which got more, but
more power. Yeah.
But again, just to demonstrate that it's actually like workable thing. we spun up this EC2 instance and put up a very simple web app in there that I'm gonna access in my browser right now.
It's a snow.com.
Yes. So it's not fast as you can imagine.
It's
but
tremendously slow.
it does what it does. So that's a web page that is loaded from this box. The web page takes a photo of the audience, runs a YOLO model on it, on eCPU, of course, because there is no GPU, and just marks the people in there. As you can see, it kind of found a lot of people. I hope it's approximately
so slow.
correct.
This is not displayed on the projector,
Yes.
but believe me, there is an image.
Oh, you
there are a
can see
lot of people that was marked by the ML model that's actually running on this piece of hardware. Hope it will show us something
I think
relatively soon.
Yeah, let me connect to the other port maybe.
No. I think you should just stop hustling with it and wait for a little.
Feel like if someone stands up, did you understand that?
No,
Yeah,
no,
you
it's
can
okay, it's
see
okay.
it. Yeah.
This is gonna work now, I think.
I hope so.
Probably.
Oh, yeah. While we're waiting for the ML model to load, oh, yeah, here it is. You can see it. We're counting the person is here, and we have a snow cone that connected physically to this MacBook, and we're doing edge compute right here, right in this room. I don't have access to my slides anymore, but I had only one slide left. It was slide for questions. Anyone is welcomed.